Go.
Hello there, y'all. Today we're going to be learning about rational expressions and specifically how to simplify them, add them, subtract them, multiply, divide, those kinds of things. So, simplifying expressions. First of all, let me just give you the definition of the simplest form. A rational expression like this one is not considered fully simplified until its numerator, the top, and the denominator, the bottom, have no common factors. Okay, so I need two polynomials on top and on bottom with no common factors. So obviously the first thing we want to do, if we're going to simplify this guy, is to actually factor it out. So I'm going to factor the top, and we're going to say 1 and 1, and probably 5 and 5. 5 times 5 is 25, and 1 times 1 is 1x squared. And then our diagonals are going to be 5 plus 5, which is 10, and that's what the middle term is. So the top of this function is going to be x plus 5 times x plus 5, or x plus 5 squared. That's the top. Now to factor the bottom, we're going to do the same thing here. We're going to get 1 and 1. 1 times 1 will give me 1x squared. And to get 20, we're going to go 5 and 4. 5 times 4 is positive 20. And our diagonals are going to be 5 plus 4, which is 9. And so that's the middle term. So the bottom factors are going to be x plus 5 and x plus 4. And so you can see that this rational expression is not fully simplified because the top and the bottom have a common factor. They both have an x plus 5. So then we're going to cancel 1x plus 5 with this x plus 5. And now all you're left with is the x plus 5 on top and the x plus 4 on the bottom. But also one thing that they'll ask you to do, which I didn't write up here, but the second part of this question is not only simplified, but to state any restrictions on the variables. And remember that what we are saying is that this expression and this expression are the exact same thing, but when you're thinking about restrictions on variables, you always have to base it on the original equation and on the resulting equation. So it is true that for the resulting equation, I can't have x equal to negative 4. X cannot equal negative 4, because if I allow x to be negative 4, then I would divide by 0, and that's bad. So x can't equal negative 4. And if I base it on the original equation, which also had x plus 5 on the bottom, then I also have to say that x can't equal negative 5. So those are my restrictions on the variable. I can't let x be negative 4, and I can't let x be negative 5. Alrighty? So this is the simplified expression, and these are the restrictions on the variables. So now I would like for you to try these. And remember again, it's not simplified until there are no common factors between the numerator and the denominator. And don't forget to state the restrictions on the variables. All right. So now, the next thing we want to do is multiply. How do we multiply rational expressions? Again, it all begins with our trusty factoring. So the first thing we want to do is factor the top and the bottom of each of the expressions. So for this top part over here, we're going to get 1 times 2 is 2x squared. And for the 3, we're going to go 3 times 1 is 3. And if I multiply the diagonals, 2 times 3 is 6. 1 times 1 is 1. 6 plus 1 is 7. And that's the middle term. So the numerator's factorization is x plus 3 and 2x plus 1. And if you're wondering what all that Chinese talk is, it's because Paul and Meng are talking in my classroom while I'm trying to record. So please don't do that. I'm pretty sure that Angela and Heidi and Yuki can understand what you're saying, and they will tell me tomorrow. So, all right, on the bottom we have x minus 4. And it says that we are multiplying, so I'm going to multiply it. And before I put over there what I'm going to multiply it by, I want to factor this guy, top and bottom. So on top, I've got a difference of 2 squares, x squared minus 4 squared. So that factorization will be x minus 4 testing if you remember these kinds of things, and x plus 4. Difference of 2 squares there. Okay, on the bottom, we'll use our trusty little plus, and we'll go 1 and 1, and then we'll do 5 and 3. And 5 plus 3 will give us the 8, which is the middle term here. So the bottom factorization will be x plus 5 and x plus 3. Alrighty? Now, one of the things that you want to do is before you start multiplying, I just want to remind you that if you were multiplying something like 2/3 times 9/4, we all know that if you have common factors on the top and on the bottom, you can reduce those first and then make the column easier. So that 2 goes into 2 once, and 2 goes into 4 twice, and 2 goes into 3 once, and 3 goes into 9 3 times. And then we can multiply across and we get 3/2. Alright, so in other words, instead of going 2 times 9 is 18, and then 3 times 4 is 12, and then reducing it because 6 goes into 18 3 times, and 6 goes into 12 twice, that's one option. You can also reduce it before you multiply. And that's what I'm trying to do over here, is before I multiply, let's reduce what we can. There's an x minus 4 on the bottom, which will cancel with the x minus 4 on top. There is an x plus 3 on the top over here, that will cancel with an x plus 3 over here, and then I can multiply and get my result. So now my answer is going to be 2x plus 1 multiplied by x plus 4. And on the bottom, we're going to get just the x plus 5. But when we state the restrictions on the variables, again, you want to start with the original problem. So we have to restrict the variables. It can't be, x can't equal positive 4, because then this will be 0. It can't be negative 5, because of the negative 5 plus 5 here. And it can't be negative 3. So those are the 3 restrictions. It can't be 4, it can't be negative 5, and it can't be negative 3. All right? And then there you go. Now the last thing you want to do is, of course, now that you're done with this part, the last part is to FOIL this out. Okay, so again, like I was saying earlier, you don't want to multiply these two and then try to multiply everything. It would be just crazy. You want to cancel everything out first, and now at the very end, it does say that we want a polynomial, and this is not a polynomial on top, okay? So the polynomial on the bottom is fine, but there's no polynomial on top. So we need to actually multiply this out, and you can do that by foiling. So my final answer is going to be first times first is 2x squared. Outside times outside is plus 8x. And then inside times inside is plus x. And last times last is plus 4. And we can simplify that to be 2x squared plus 9x, because we're going to combine 8x and 1x. And then plus 4, all divided by x plus 5. This is the simplified rational expression. It meets the requirements of having a polynomial on top, a polynomial on the bottom, no common factors, and these are the restrictions on the variable. So now you can try this guy. And the last thing we're going to do is division, but you probably already know that dividing is the same thing as, dividing by a fraction is the same thing as multiplying by the reciprocal. So the first thing I would do is, the good news is that this problem is already factored, everything's already factored, so that's nice. But we're going to rewrite it as 4 minus x divided by 3x plus 2. And instead of dividing by this, we're going to multiply by the reciprocal. That's how you divide when you're dividing by a fraction, is to flip it over and multiply. So now the x minus 2 is going to be on top with the 7y minus 5. And on the bottom, you're going to have the 5 times x minus 4. Okay? And now we want to see if we can cancel out any common factors. And of course, the x minus 2 cancels. And then you might be thinking to yourself, why this x minus 4 looks a lot like this 4 minus x, but it's not exactly correct yet. You can actually rewrite this in the right order. It would be negative x plus 4, because the x is negative and the 4 is positive. And then you can factor out the negative. So this would become negative 1 out here, and then you would have x, because negative 1 times x is negative x, and then you would put negative 4, because negative 1 times negative 4 is positive 4. And so now this would replace the 4 minus x, and now you can see how you can cancel the x minus 4 with the x minus 4, but the negative 1 is still there. So what we have left so far is the negative 1 on top over here. We have the 3x plus 2 on the bottom of this guy. We have the 7y minus 5. And we have the 5 on the bottom. That's all you have left. As far as restrictions on the variables, x cannot equal, and you start from the original function. So it can't equal, in this case, it's going to be negative 2/3. There went the bell. It can't be 4, and it can't be, and that's it. So those are the only two. Oh yeah, and it can't be 2. So it can't be 2 because of this. And just so that you know what I'm doing, with the 3x plus 2, I want to know when it's going to equal 0. So if you're wondering where I got negative 2/3 from, I just subtract 2 and then divide by 3. And that's how I got that x can equal negative 2/3. All right, so that's where this guy comes from. Obviously the 4 here can't be 4, can't be 2. So you have 3 restrictions on the variable x. And then our last step is to simplify this guy. So you're going to want to distribute the negative to this. So you're going to get negative 1 times 7y is negative 7y, and negative 1 times negative 5 is positive 5. And on the bottom, you're going to have 5 times 3x, which is 15x, and 5 times 2, which is 10. And this is the simplified expression, and these are the restrictions on the variables. So now you can try this example, and once you have done that, you will have completed the lesson for today. Thank you.